Hello everyone, I am Mohammad Khalid and welcome to my YouTube channel Physic-so-Mathematica Techno-Computa. In this video, I am going to solve the lead code problem, and problem number is 605 and problem title is Can Place Flowers. So problem goes like this: you have a long flowered bed in which some of the plots are planted and some are not. However, flowers cannot be planted in adjacent plots, and given an integer array, uh, array name is flower bed containing zeros and ones, where zero means empty and one means not empty, which means one means flower is placed in that particular position. And an integer en, if en and they'll give some integer n, return n new flowers can be placed in the flower bed without violating the non-adjacent flower bed, which means they'll be giving some n flowers. We have to check if that n flowers can be placed in the flower bed or not. Now let me explain problem clearly. It is saying we have flower bed of this type long, and then there are some sections. Let's say the flower is placed in this position initially, and then here it is placed, and then here it is placed. So as you can see, here flower is placed, and in the next section flower is not placed. So this satisfies the adjacent rule. Here also same case, and in this case also same thing. Right side there is no place, and then left side we have an empty space, which means the adjacent property satisfied. Now the first case is like will be given flower bed where there are 5 slots in which at the beginning and at the end flowers are placed, but in between 3 places there is no flower placed, and they'll give one flower. We have to place it in such a way that adjacent property is satisfied. So the given case is like this: 3, 4, 5. So they placed flower here, and they have placed flower at the end. Now 3 spaces are empty, and they have given n equals to 1, which means they have given one flower. We have to place in such a way that adjacent property satisfied. If we place flower here, so what happened is here we don't have flower, but the thing is here we have flower, so adjacent property is not satisfied. So we should not place uh, in this position. Let's say we place in this position. So if we place the flower in this position, so right side if you see there is empty, and left side if you see there is empty. So this satisfies the uh, like we can place the flower. So we have to return true in this case. And one more same case, but they'll give some like 2 flowers they'll give. So when n equals to 2, so we have found one place. First initially they again like first place they have filled the flower, and then at the end, so one flower we have placed at this position. Now if we try to place one more flower, we can't. If we place at this position, so left and right like adjacent property is not satisfied, so we can't place it here. If we place here also same thing happens. So in this case we have to return false, which means we can't place the all flowers given. So this is the problem statement given. So before solving this problem, I want to discuss some one more cases. So basically, there are 3 cases in which we can place the flower. Uh, First case is in, let's say we have flower bed of this type, uh, and then in order to place in between any flower, there should be 3 empty slots. Then only we can place the flower, uh, because if there are only two, so we can't place it. Let's say we have here only 2 spaces, so if we try to place it here, adjacent properties violated. So there should be 3 slots empty in between any 2 flowers. And one more case is like end cases. End cases are of this type. Let's say this is the first end, like left end of the array. array, you can say, or flower bed. So now in this case, uh, since there is only one flower bed, I mean right side, in this case there was we have to place the flower in between. Here we have one flower, and here we have one more flower. But in this case we have only one flower, but the left side there is no flower. So in this case two slots are good enough to place the flower. So here we can't place it, but here we can. And last case is of this type. uh, Same thing, but the thing is this flower place right side, like we have suppose of this type. So here we can't place the flower, but the thing is here we can place the flower. So these three cases we are considering. Now let's code our program. uh, First of all, what we'll do is we'll check if n is empty. If n is 0, which means we don't need to place any flower in the flower bed. So already the flower bed will be in adjacent condition satisfying, and we have to check only for the thing when we place the new flowers. So when there is no flower to be placed, then already this adjacent condition is satisfied. So the flower bed is true, so we have to return true. Now the case is, let's say we have only one flower, like one flower. This array length is one. Okay, array length is one. So which means we have only one slot. So what we can do is, first we have to find the length. Let's say int length is equal to flower bed dot length. Okay, length we have found. Now we have to check if length equals to one, and if like let's say we have only one slot, and in that slot the flower is already filled. So we can't place any flower. So in that case we have to return false, because uh, the condition of n is handled here for 0 case, and n can't be negative, as they have given, I guess. Yeah, n can't be negative. N can be greater than 0 and less than flower length. So 0 it can't be. So negative it cannot be. 0 cases handled. Now positive cases. So length is 1, and in flower bed in 0th position we have, let's say, flower. So we can't place it. We can't place any flower. So we have to return false. Now one more case is, let's say length is 1, and flower bed of 0, which means at the, like, we have only one flower spot and that spot is empty. Also if n equals to 1, which means we have only one flower to be placed. In this case we have to return true. Now we have to take, let's say, one variable I, and we have to run a loop which is less than equals to length minus 2. uh, the reason why I'm taking length minus 2 is I'm taking these conditions, these cases, like we'll try to iterate all through these flower beds or array, and then at this step, uh, till this step will come, we'll check if after this step we have two empty slots or no. So that is the reason I'm taking length greater less than equal to minus 2, length minus 2. Now as I've discussed boundary cases, this case initially we had two empty slots, and then at the end we have two empty slots. If this case is there, we have to check, like, if I is equal to 0 or I equals to length minus 2. In this case we have to check if flower bed of 0 equals to 0, and also flower bed of I plus 1. Next slot we are checking if that is 0. If both are 0, then what we can do is you have to reduce n one time, and then we have to increase the I, which means basically we have placed one flower in the spot. This indicates that only we have placed the flower. If this is the case, so if this condition not satisfied, which means there both the slots are not empty or either one slot is not empty. In this case, we have to simply increase the I position. This was the case of the first and second case. These two cases. Now this case is we are checking if we have to find three consecutive empty spaces. So if I here it should be I not 0. If I equals to 0 and I plus 1 0 and flower bed of I plus 2. So which means we have found three consecutive empty spaces. So we can place one flower. In minus minus 1 indicates we can place one flower. And now in this case, uh, it is something like this. We have placed this flower. Like position of I was here, and I plus 1 is here, and I plus 2 is this. So we have placed here one flower. So next, since I was here, we should not direct. We should directly put I to this position. We should not check here because as we know I is flower is there in this position. So in order to understand this clearly, let me take one case. Let's say we have one flower and we have one more flower here. So our I position is here, let's say. Here also let be one flower. So in this case we can place one flower here. Our next I position will place it here. So here also we can place flower. That is the reason uh, I'm putting as I is equal to I plus equals to 2. Else if this condition are not met, then simply we have to increase I. And if n is less than 0, which means we have placed all the flowers. If you place all the flowers, n will be 0, and then in this all cases n can go to negative because there may be some other slots, empty spaces where we can place flowers. So n can be less than 0 also. So we have, in this case we have to return true. Else what we are doing is we are just returning n equals to 0. Let's run this code. Okay, both the test case is satisfied. Now let's submit the code.